Now I will discuss about the greatest integer function. Greatest integer function. First of all, what is greatest integer function? It is box of x, and that denotes integer that denotes greatest integer less than equal to x. Suppose we have to find the value of box 2.1. But the largest integer which is less than 2.1 is 2, so it is equal to 2. Suppose I have to find box of 3.8. Now the largest integer which is less than 3.8, it is 3. Suppose minus 2.7. The largest integer less than minus 2.7 is minus 3. If it is 5, then the largest integer equal to this is 5, so it is 5. So one question, that is, if x equal to I plus f, where I is an integer and f be a positive proper fraction, then box x or box of I plus f is definitely equal to I. It is very important. So box x equal to box of I plus f equal to I. Now I'll discuss some problems on the greatest integer function. First of all, 13 into box x plus 26 into box x plus 39 into box x square equal to 2019. Then find the number of solution of this equation. Now the left hand side, we can say that it is 13 into box x plus 2 box x plus 3 box of x square equal to 2019. Now box x plus 2 into box x plus 3 into box of x square equal to 2019 by 13. Now we know that 13 does not divide 2019, so it is not an integer. But the left hand side is integer as box x equal to the largest integer less than equal to x. Similarly, box x square equal to the largest integer less than equal to x square. So left hand side is an integer, but right hand side is not an integer. Therefore, number of solution of this equation is 0. Not possible to say this is equal to this for any value of x. Now I am coming to the next problem. Suppose I have to find the value of box x plus box of minus x when x is not an integer. Now, starting with this one, box of minus x. If x equal to I plus f, then box of minus x equal to minus I minus f. Now what I have told just before, that box x equal to I plus f, where f lies between 0 to 1, and here the fractional part is minus f, which lies between minus 1 to 0. Therefore, we have to convert this functional part, we have to convert this fractional part into that region such that it lies between 0 and 1. So how can I do? We have to write minus I minus 1 plus 1 minus f. Now this is the fractional part which lies between 0 to 1. Therefore, it is equal to minus I minus 1, and which is equal to minus box x minus 1. So box of minus x equal to minus box x minus 1. Therefore, the value of this is box x minus box x, box x minus box x minus 1, and which is equal to minus 1 when x is not an integer. And again, minus box x equal to minus x when x is an integer, such that box of minus 2 equal to definitely minus 2, and so on. So what we have got? We have got box of minus x equal to minus box x minus 1 when x is not an integer, and box of minus x equal to minus box x, minus box x when x is an integer. One question. Suppose it is given that fx equal to box x plus k is an odd function. Then find k. First of all, if I replace x by minus x, then we will get f of minus x equal to box of minus x plus k, and which is equal to minus box x minus 1 plus k. Now, as fx is an odd function, therefore f of minus x equal to minus fx, and that implies f of minus x equal to minus of box x minus k. Therefore, these two are equal when fx is an odd function. Now, minus box x minus k equal to minus box x minus 1 plus k. Hence, we will get 2k equal to 1 and k equal to half. So for k equal to half, box x plus k becomes an odd function. Now I can do some tremendous problem using this one. Suppose you are given an integration minus 100 to plus 100 box of x cube dx. Now what can I do? The limit indicates minus 100 to plus 100. That means if it is odd, then the answer will be 0. But unfortunately, box of x cube is not an odd function. So how can I make this function odd? Just I have to add a plus k, which is half. So if I do this thing, that minus 100 to plus 100, box of x cube plus half dx minus 100 to plus 100 half dx, then this portion is odd, so its value is 0. And for the next portion, just I have to integrate simply, and which is minus half into x minus 100 to plus 100. Therefore, the answer is minus 100. Okay. Now, another topic on this, which is very important. There is an identity which is box x plus box of x plus 1 by n plus box of x plus 2 by n. In that way, box of x plus n minus 1 by n equal to box nx. It is an identity where n must be a natural number. Now question is that how can I prove this? Let fx equal to box x plus box of x plus 1 by n plus box of x plus 2 by n up to box of x, sorry it is plus, x plus n minus 1 by n. Now, f of x plus 1 equal to box of x plus 1, box of x plus 1, pardon, now f of x plus 1 by n equal to box of x plus 1 by n plus box of x plus 2 by n plus box of x plus 3 by n, it goes up to box of x plus n minus 1 by n plus 1 by n. So what we have got? That is x plus 1 by n, x plus 2 by n, x plus 3 by n, it is up to x plus 1. Now, this box of x plus 1, this box of x plus 1 equal to box x plus 1. Box of x plus 1 equal to box x plus 1. Therefore, f of x plus 1 minus n equal to box x plus box of x plus 1 by n to box of x plus n minus 1 by n plus 1. Now, if we consider gx equal to box nx, if we consider gx equal to box nx, again g of x plus 1 by n is n into x plus 1 by n, and which is equal to box n x plus 1. Again, 1 is an integer, therefore box n x plus 1. Hence, it is clear that f of x plus 1 by n minus fx equal to 1 and g of x plus 1 by n minus gx equal to 1 for all values of x. But this one happens when these two functions are parallel or these two functions are identical. Now question is that we can find a point x equal to 0 where it is 0, it is also 0, it is 0 and it is 0. So whole thing is 0 at x equal to 0. Also at x equal to 0, box of nx is 0. Therefore, these two functions are not parallel as they intersect at x equal to 0. Therefore, these two functions are definitely identical. So what I have said, under such condition, when we have same increment for two functions for the same increment of x, then we will get two cases, either they are parallel or they are identical. Now here fx and gx intersects at x equal to 0, therefore they are not parallel. So only option left, which is they are identical. Hence we can say that fx equal to gx. And this is the proof of the famous identity box x plus box of x plus 1 by n up to x plus n minus 1 by n equal to box nx. Okay. So following that, I can say that box x plus box of x plus half, here n equal to 2.